Ladies and gentlemen, this is Ms. Dubois helping my Algebra 2 Goal 4 peeps yet again. The following topics that we're going to be doing are the ones that are highlighted: how leading coefficient affects the shape of a parabola, which is a pretty easy one, but there are a couple of things to keep in mind. Rewriting a quadratic equation defined as vertex and sketches graph, word problem involving max or min of a quadratic, and then writing the equation of a function given its graph. Wow, I can talk. Again, as always, you want your perfect squares 1 through 20 somewhere handy that you can write them down. And also, as always, you want the quadratic formula. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So most of these topics that I'm going to be going over actually kind of use the same strategy, but I want you guys to get used to a couple of things first. So we are going to start with this right here: how leading coefficient affects the shape of a parabola. The most important thing that you want to keep aware of is a nice little cheat sheet of notes for yourself. So first things first, if it opens up, it is a positive coefficient, LC for lead coefficient. If it is negative, then if it is opening down, then it is a negative lead coefficient. So this is opening up, so therefore it's positive, so this is going to be positive. This is opening up, so this is going to be positive. This is opening down, so that's going to be negative. That's opening down, so that's going to be negative. Next, when you're getting this one, the coefficient that is closest to 0, what they're looking for is your widest graph. And what they mean by that is also your lowest fraction. And we'll talk about that in one of the later examples. So what is our widest graph here? And probably B. That one looks pretty wide. Next up, you're looking for the least value. That one has two conditions. First thing, because it's least, we need it to be negative. Then, because it's least, we need it to be narrow. Those are the two conditions that you're looking for, negative and narrow. So negative is these two. Which one is narrow? That's going to be D. Pardon me. So that's the visual kind. This particular topic comes in two flavors when you're looking at it. Whoa, what happened? This topic comes in two flavors when you're looking at it, so you want to be careful. So we'll give you another one of the graph type where they give you the pictures. Some students tend to find that a little bit easier. So if we're looking at this one, let's see here. Positive or negative. So this one is going to be positive. This one, letter B, that's opening up, so it's going to be positive. This one is opening down, so it's going to be negative. This one is opening down, so it's going to be negative. Closest to 0, that's a fancy way of saying widest. So which one is our widest? It's actually B. Don't tell me this is the same one both times. No, not completely. Okay, good. Next up, we want the least value. Okay, I'm going to switch this for a second because I want to show you. The other way they'll write it, they will ask what is the greatest value. And those are two different conditions. If it's greatest, then you want a positive and you want a narrow. So if it is least, you want negative and narrow. If it is greatest, you want positive and narrow. Positive and narrow is going to be A. So that's what they look like for this particular topic when you have it in a picture format. But like I said, this topic comes in two flavors, because sometimes they just give you the coefficients and the horror, how am I supposed to do that? Actually, low-key, it's kind of easy. So whether it opens up or down, we talked about it before. If it opens up, it's positive. If it opens down, it's negative. So this one is going to be opening down because that's -4. That's going to go up because it's +1. Positive 2/3 means it's going up. 3/4 means it's going up. So far, so good. Now for the widest graph, what that means when they're looking for widest. What was it that we were looking for up here? Let's see here. Widest meant coefficient closest to 0. So that's closest to 0. And what they actually mean is what's your smallest fraction. That's ultimately what they're kind of looking for. So these are whole numbers, so I automatically know that they are crossed out. Which one is smaller, 2/3 or 3/4? 2/3 or 3/4? 2/3 is the smaller fraction. Next up, narrowest graph. Again, key phrase, narrowest. So that means you want your biggest number. So in this case, over here we have a 1 and we have a 4. Which one is bigger? The 4. The sign does not matter here because they're looking for narrowest. If I'm looking at regular x squared, it looks like that. If I look at negative 4x squared, it looks kind of like that. So obviously that one is my narrowest, and that's what we're going to be going for. One more take. Scroll down a little bit here. For each parabola, choose whether it opens up or down. This is negative, so it opens down. Positive 1/3, so it opens up. Positive 1/2, it opens up. Positive 3, it opens up. Okay. Narrowest graph, we just want our biggest number. So we have a 3 and we have a 4. 4 is the bigger number, so that's the one that fills in. Widest graph. Widest graph means closest to 0, which means your smallest fraction. So what's smaller, 1/3 or 1/2? 1/3. So that's one topic done and taken care of. There are two types of flavors for this. They'll either give you a graph or they'll give you the leading coefficients. And the type of questions they ask change very slightly, but ultimately they're basically asking the same thing. So this was the odd topic out. When I go back to my list, this one has now been taken care of. And now these three all kind of are based on the same thing. So what I want to do is I want to show you what they're doing because we're pulling something from goal 1. All right, so give me a second to take a sip of water. Now, not a lot of students will give me questions on this particular topic, even though it's one of the easier topics that's in the chapter. The thing is that there is a throwback to goal 1. So let's see if I can jog your memory here. Do you remember f of x equals parentheses x plus or minus h squared plus or minus h? This was a big thing on the PA. If you recall, you would be giving something like 2x minus 1 quantity squared, and then you had to be told it was a stretch factor of 2, and then that you were going right 1. That's the kind of stuff that we're pulling from for this particular topic. So, quick review if you've forgotten all the way back from first quarter. If you are inside parentheses, you are going left and right. If you are outside parentheses with that plus h, you're going up and down. This should look familiar from all of the PA reviews I did at the beginning of the year. And here's the really cool stuff. There's your x, and there's your y of your vertex. Oh. So if I'm looking at this particular one, that's the important number right there. That's my vertex, right? So then what that means is I actually know what the numbers are going to be for most of this, because it's going to be x, 2, and then 3. Now I got to be careful here. Negative 3 means I'm going down, so it's minus 3. Then negative 2 means I went left. Left means it's going to be plus 2. So most of my equation actually doesn't need that much thought because I have my vertex there. Now what they do is they will give you a second point, but it's not always a convenient one. Is this one going to be convenient? Yes, it is. What I like to do is I will move over. If this is my vertex, I'm going to move over 1 block. Then 1 block. Here's my hint. Then where is it next on the blue line? Right there. How far down did I move? I went down 1, negative 1. There's my number. Negative 1, x plus 2, quantity squared minus 3. That's a little hack Ms. Dubois has as a professional math teacher in order to help you guys figure out how to write your equations. And you could technically FOIL this out, combine your like terms, and make it look more like standard form, which is usually what this looks like, ax plus bx plus c. But this is just as viable, and it will be accepted as correct in the software. So let's pull out another example. So we have our x plus or minus h plus or minus k. This takes care of my left and my right. This takes care of my up and my down. Now, technically, Ms. Dubois doesn't need to write this anymore because I've done this so many schnitzel times. But for students who need the refresher from goal 1, absolutely write it down and make yourself comfortable. These are the numbers I'm going to be using because these are the numbers on my vertex, right? So what do we have? We are going to have x plus 5. We're going plus 5 because we went to the left, and then we're going to go plus 3 because we went up 3. So we went left 5 and then up 3, right? Next, we got to figure out what number goes here. So I'm going to go over 1, and then I'm going to go down how many? 3. So negative 3x plus 5 quantity squared plus 3. And that would be my answer. And that's basically how straightforward this particular topic is. And FYI, if I go back and look, I'm 90% sure that this is a DSA question. But it takes a while. You need to remember your goal 1 stuff. So let's do a couple of more, and then I'll move on to some easier stuff. So there's my vertex. Let's see here. So x plus or minus h plus or minus k, that takes care of my left and my right, that takes care of my up and my down. Okay, so it will be x plus 5 quantity squared minus 3 because I'm going down. So far, so good. Next, I go over 1, and then there's my point on my line. What did I do? I went down 2. Negative 2, x plus 5 quantity squared minus 3. And I'm starting to do it a little faster as I get more comfortable with what I am doing. Next up, last problem. So what do we have here? There's our vertex, all right? So what do we have? We have x plus or minus h parentheses squared plus or minus k. That takes care of my left and my right. That takes care of my up and my down. So 3 and 7, so it's x minus 3 because I went right, and then it is minus 7 because I went down. Next, I go over 1. There's my point on my line. So you can see how sometimes it's nice to you when they give you an actual point. I went up 3. So it's 3 over 1, therefore 3 parentheses x minus 3 quantity squared minus 7. So that's 4 separate problems I've done for you guys for this topic at varying degrees of speed, slowly getting faster as we go, as we become more comfortable with the topic, all right? So let's see here. Writing given its graph, that is now check. There's another one done. These last 2 problems, you're actually doing the exact same thing. Let me get used to what it's doing first. Okay, so rewriting a quadratic, I think, is the next one I have on the list. Yep. Okay, so there is a couple of ways that you can do this, but this is actually using, I find personally, the easiest thing is to use a skill set we used from a bunch of earlier topics in my last video. So in order to find the vertex, we're actually going to do that first, and then we're going to write it in the form specified, since we now have all of this information pre-existing in our heads. So what do we do? If you recall, if you don't remember from Friday, this is going to be opposite b over 2a, right? That's going to get us our x. So what is opposite b? So there's our a, there's our a, there's our b, there's our c. So it's going to be opposite b, so opposite 18 over 2 times a, and what's a? Negative 3. So that's going to be 18 over negative 6, which is in fact negative 3. So our vertex is going to be negative 3 comma something. So far so good. Should be familiar. We've done this before. Now that we know what our b is, we are going, or b, our x. Now that we know what our x is, we're going to plug it into the equation in order to find our y. So negative 3 times negative 3 squared minus 18 times negative 3 minus 26. So negative 3 squared is 9. 9 times negative 3 is negative 27. Double negative is a positive. 18 times 3 is 30, 50, 54, minus 26. 27 and 26 is 53 plus 54. Our last answer is going to be 1. There's our vertex. And you know what? That's the form we're looking for. And we have the number we want. Because if we remember, we were using the vertex here, 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 everywhere. So now that we know, now that we know what the vertex is, we actually know what our format is going to be. We know that it is going to be, let's see here, where do I have space? There's our final answer. We have x, we're going left 3, so it'll be plus 3 squared plus 1. The last question we have is what number goes here? They tell you. Negative 3. There's your answer. So the sheer brute force work is stuff that you've been doing as practice in earlier chapters. And then they give you literally give you the last piece of the puzzle that you have. And honestly, even though the topic looks a little bit scary, this isn't that bad. So let's go through another example, and I'm not sure I gave myself enough room. So we're going to start with opposite b over 2 over 2a. So there's our a, there's our b, there's our c. So it is going to be negative 30 over 2 times a, so 3 times 2. So that's negative 30 over 6, which is negative 5. So it's going to be negative 5 comma something. So again, opposite b over 2a, that gives us our x, and now we take that x and we're going to plug it into the entire thing. So 3 times negative 5 squared plus 30 times negative 5 plus 74. 5 squared is 25, 25 times 3 is 75, minus 150 plus 74, so that's going to be 149 minus 150, which is negative 1. Boom. Alright, so now we have this format. So what do we have? We have x plus 5 squared minus 1, because there's my x, and then there's my y. Next up, what's the number that goes in front? Positive 3. And you start to realize, oh wait, this actually kind of low-key isn't that bad. We can become a little bit more comfortable with this as we go. In fact, it's easy enough that I only put down 2 problems because I feel as though this is enough for you guys to understand what it is that you are looking for. So that's another topic of our list that is done, rewriting to find its vertex. Next up, word problem involving maximum or minimum of a quadratic formula. The hint here is actually given right there, the maximum or minimum of the quadratic formula. So all the stuff we were doing down here, shock of all shocks, we're doing it again. And you start to realize that for goal 4, there's basically 2 to 3, what do I call them, skills that you're just using over and over and in different contexts. So let's go through some examples. A vehicle factory manufactures cars. The cost is C. Unit depends on the number of cars. If X cars are made, the unit cost is given by blah, blah, blah. So they give you the format right there. How many cars must be made to minimize the cost? This is going to be the key phrase here. They are going to give you, do I have all 3 types? How many machines must be made to minimize the cost? And then how many cars? Okay, so the 3 screen grabs that I pulled from the internet are all asking for the same thing. What they're going to do is, basically, they're going to ask you how many to be made, or they're going to ask for the minimum, maximum cost. Based on which one they're asking, then you know from your vertex you're either going to be finding your x or your y. That's what you got to be aware of. So in this case, it's how many cars must be made. So therefore, we're looking for our x, and oh gosh, how do we do that again? What's the thing that we have been doing over and over and over again? Oh yeah, opposite b over 2a. So opposite b is 72 over 2 times 0.4. So that's going to be 72 over 0.8. And I do not know that off the top of my head. Let me pull out my calculator. Alright, so it's going to be 72 divided by 0.8, and that's basically multiplying by 5/4. So what's it going to be? 90. Okay, so then our x equals 90. And there's our answer. Next one. I want to give you, let's see here, I'm going to cross this out for a second. How many cars? I don't want it to ask that. I'm going to ask, what is minimum cost? Because I want you to get used to the y's. So, what are we going to do? Opposite b over 2a, so that's opposite, so that's 342 over 2 times 0.9, which is 342 over 1.8. So let's do that out. That is 342 divided by 1.8, 190. So that's 190, and now all we have to do in order to find the y, because it's asking for our cost, that's our y, so we got to take our 180, which is our x, and plug it back in. So 0.9 times 190 squared minus 342 times 190, Ms. Dubois, plus 40 1,448. Okay, do I have the fancy calculator? Yes, I do. So 190 squared. Nope, I don't think that worked. Oh, it did. Good. And then it's going to be times 0.9 equals. So 32,490. 32,490. And then it's 342 times 190 equals. So it's going to be 64,980. So minus 64,980 plus 44,48. So that's a mess to do. So 32490 minus 64890 plus 44,8 equals, and then there's our answer, 8048. 8048. That's basically low-key all you're doing. You're either finding your x or your y. Y is a little bit longer because you need to find your x first, but it's pretty straightforward. And ooh, I did not give myself space. Boo. How many machines must be made? So that's opposite B over to A. And you'll notice I didn't even read the problem. I just looked at the last question. How many machines? That's my x. And since they gave me the formula, it doesn't even matter what the context of the rest of this is. So it's opposite B over 2A. So it's going to be 100 over 2 times 0.2, which is 100 over 0.4, which I feel like I know that. I feel like that's going to be 400. No, that doesn't sound right. Let's find out. 100 divided by 0.4. This is a simple decimal, and I'm going to kick myself. Yeah, it's 250, Miss Dubois. Good job. So our answer here will be 250. And then that's all you're doing. So that is, look at all of the math we did for the last 20 minutes. Not bad. So that is all the topics that we have for today, and that's also the last of the topics for this particular family. I'll have another set of family topics loaded up for the next one. There's a lot of topics still to cover for Algebra 2 Goal 4. Guys, don't worry, I got your back. We'll get you through this. Stay happy, stay healthy, stay safe.